In this lecture, I would like to discuss simple linear regression. Please treat this lecture as a very quick introduction to the very large world of the science called econometrics, which we will discuss with you in the next semester. I will start with the short introduction. After this, I will discuss something called probabilistic model. Then I will show you how the model can be estimated, how it can be fitted. After this, I will discuss 4 assumptions of the simple linear regression. After this, I will show you how to do hypothesis testing for the estimated model, and I will finish the lecture with the discussion of 2 coefficients, small r, which is the coefficient of correlation, and large R squared, which is the coefficient of determination. In the previous lectures, we've assumed that the mean of a population is constant. Starting from this lecture, we will relax this assumption and we will treat the mean of a population as a variable, so something that is not constant. And we will treat the mean of the population as a variable which will be dependent on the value of another variable. To give you an example, let's consider the mean sale price. We know that there are a lot of factors which can affect the mean sale price of a house, and one of those variables is the square feet, so the size of the house. And let's assume that with each increase in the square feet of the house, the mean sale price increases by $60. So as you can see now, the mean sale price is no longer constant, but it is dependent on the size of the house. Another example of such a dependence could be the dependence of the mean reaction time on the amount of a drug in the bloodstream, or the dependence of the mean starting salary of a college graduate on the student's GPA. And another example could be the dependence of the mean number of years to which a criminal is sentenced on the number of previous convictions. So if you look at this model for the mean sale price, you can see that this is a simple model, and it will be a straight line with the intercept of 30,000 and the slope of $60. And we call this a straight line model, which is the simplest of all models which help us to show the dependence of a populated mean value on another variable. And to estimate such a straight line model, we use simple linear regression analysis, which in other words is the methodology that is used for estimating and working with the straight line relationship.